Standard Mathematics, Chapter 7, Variations, Module 1. In this chapter, we'll study different types of variation, mainly the two types, that is, the direct variation and the indirect variation. First, let us understand what is variation. Suppose one notebook cost for ₹10. Let us observe the following table and understand the concept of variation. So if you see in this table, number of notebooks denoted by X, cost of notebooks is Y. So one notebook costs for 10 rupees, 3 notebooks cost for 30 rupees, 5 notebooks cost for 50 rupees, 7 notebooks for 70 rupees, and 10 notebooks for 100 rupees. If you note one thing, as the variable X changes, the variable Y also changes. So the changing of variable parameters is called as variation. There are two types of variation, in that the first type is called as the direct variation. The second is called as the indirect variation or inverse variation. Let us first understand what is a direct variation. In a variation, if variables changes proportionately, that is, either increase or decrease together, then it is called as direct variation. If X is in direct variation with Y, then it can be symbolically written as X directly proportional or indirect variation with Y. This is the mathematical representation of direct variation between two variables X and Y. X directly proportional to Y is written in the form of equation as X is equal to Ky, where K is a constant. X is equal to Ky. If we take K on the other side, this equation can also be written as X upon Y is equal to K. This is the equation form of the direct variation, where K is the constant of variation. Observe how the following statements are written using the symbol of variation. First, area of a circle is directly proportional to the square of its radius. So, area of the circle denoted as capital A, radius denoted as R. The above statement is written as in the form of symbol of variation, A in direct proportion to R square. As it is said, area of a circle is directly proportional to the square of its radius. Second one, pressure of a liquid denoted by P varies directly as the depth D of the liquid. This statement is written as P in direct proportion with D. Let us start with the practice set 7.1. This is the first question in practice set 7.1. We have to write the following statements using the symbol of variation. So the first one, circumference of a circle is directly proportional to its radius. Second one, consumption of petrol in a car and distance traveled by that car D are in direct variation. So let us start with the first one, circumference of a circle is directly proportional to its radius R. This statement is written as C in direct proportion to R. Second one, consumption of a petrol, that is denoted as L, in a car and distance traveled by that car denoted by D are in direct variation. This statement is written as L in direct proportion to D. Second question of practice set 7.1. You have to complete the following table considering that the cost of apples and their number are in direct variation. The number of apples denoted as X, cost of apples denoted as Y. It is given that the cost of apples Y and the number of apples X are in direct variation. So in form of symbol, this will be as Y in direct proportion or in direct variation to X. This, if we write it in the form of equation, it becomes Y is equal to Kx, where K is called as a constant of variation. Now in the first column here, X is 1 and Y is 8. So when X is equal to 1 and Y is equal to 8, we can use this to find out the value of K. So K will be equal to 8. Now since we have found out the value of K, we can find out the remaining missing values from the table. So if we see, so the equation of variation will be Y is equal to 8x. So in place of K, we have substituted the value of K, that is equal to 8. Now we need to find out the missing values in the table. The equation of variation is Y is equal to 8x. Now, if you see, when Y is 56, we need to find out the value of X. So we'll use this equation of ours. In place of Y, will substitute 56. So 56 is equal to 8x. If we divide both sides by 8, we get x is equal to 7. Similarly, if you see in the second last column, when x is 12, we need to find the value of y. So we'll substitute in place of x, we'll substitute 12 in this equation of variation. So y is equal to 8 into 12, which is 96. And last one, when y is 160, we need to find the value of x. So we'll substitute in our equation of variation. So this becomes 160 is equal to 8x. And if we divide both sides by 8, we get x is equal to 20. So the missing values in our table is 7, 96, and 20. Let us move on to the next sum. Practice set 7.1, question number 3. If m is in direct variation with n, and when m is 154, n is 7, we have to find the value of m when n is equal to 14. Let us start with the solution. It is given that m is in direct variation with n. So if we write this in the form of equation, it becomes m is equal to kn, where k is the constant of variation. Now in the question it is said m is 154 and n is equal to 7. We'll use these values to find out the value of k. So substituting it in the above equation, m is 154, k has to be found out, n is equal to 7. Now if we divide both sides by 7, we get k is equal to 22. Therefore, the equation of variation is m is equal to 22n. So in this equation, we have substituted the value of k, which is 22. Now, in the question they have asked, when n is 14, we need to find the value of m. So we'll substitute it in our equation of variation, m equal to 22n. So m is equal to 22 into 14, which is 308. So the value of m is 308. Next, let us do practice set 7.1, question number 5. In this question, it is said, y varies directly as square root of x. When x is equal to 16, y is equal to 24, we have to find the constant of variation and equation of variation. Let us start with the solution. It is given that y varies directly as square root of x. Now, in the symbol of variation, this will be y in direct variation with root of x. If we write this in form of equation, this becomes y is equal to k into root x, where k is the constant of variation. Now, when x is equal to 16 and y is equal to 24, which is given in the question, using these two values of x and y, we will find out the value of k, that is the constant of variation. So we'll substitute it in our equation. Y is 24 equal to k into under root of 16. So we know square root of 16 is 4. So we get 24 is equal to 4k. We divide both sides by 4. We get the value of k to be equal to 6. Now we have found out the constant of variation and equation of variation. The constant of variation is 6. We'll substitute it in our equation of variation. So we get y is equal to 6 root x. So our equation of variation is y equal to 6 root x. Let us move on to the next sum of practice set 7.1. This is the sixth sum. In this sum, it is said the total remuneration paid to laborers employed to harvest soya bean is in direct variation with the number of laborers. If remuneration of 4 laborers is rupees 1000, we have to find the remuneration of 17 laborers. The meaning of remuneration is the salaries paid to the laborer. Let us start with the solution. Let the total remuneration paid to laborers be rupees y. So we'll consider the total remuneration which is paid to the laborer as y, the variable y, so rupees y. And the number of laborers employed be x. So the variable x is the number of laborers employed. It is given that y varies directly as x, as it is mentioned in the question. So the symbol of variation will look like y in direct variation with x. Now, if we have to write this in the form of equation, so it will look like y equal to kx, where k is the constant of variation. Now, when x is 4, that means when 4 laborers are there, the total remuneration paid to 4 laborers is rupees 1000. That means when x is 4, y is 1000. Using these two values of x and y, we'll substitute it in our equation of variation and find out the value of k, that is the constant of variation. So we'll substitute y is equal to 1000, x is equal to 4. So we have 1000 is equal to k into 4. Now here we'll divide both sides by 1000 to get the value of k. So 1000 divided by 4 will be 250. So the value of k, that is a constant of variation, is 250. So now we'll substitute the value of k in our equation of variation. So the equation of variation will be y is equal to 250x. Now in the question, it is said when there are 17 laborers, that means when x is equal to 17, what will be the value of y? That means what will be their remuneration? So in an equation of variation, we'll substitute the value of x as 17. So we get y is equal to 250 multiplied by 17. So 250 multiplied by 17 is 4250. That means For 17 laborers, the total remuneration is rupees 4,250 rupees. Thus, the final statement would be the total remuneration of 17 laborers is rupees 4,250 rupees. In this sum, the cost of groundnuts is directly proportional to its weight. If cost of 5 kg groundnut is rupees 450, then find the cost of 1 quintal groundnuts. In the question it is mentioned 1 quintal is equal to 100 grams. With all of this information, let us start with the solution. Let the cost of groundnuts be X and the weight of groundnuts be Y. It is given that X varies directly as Y. Therefore, the symbol of variation will be X in direct proportion with Y, and in the equation form will be X is equal to KY. It is given that when X is equal to 450, then Y is 5. That means for 5 kg of groundnut is 450 rupees. Using these two values, we'll find out the value of K, that is the constant of variation. So we'll substitute the values. 450 is equal to 5K. Here, if we divide both the sides by 5, we'll have K is equal to 450 upon 5, that is 90. So the constant of variation K is 90. Substituting this in our equation of variation form, we have equation of variation as X is equal to 90Y. So now if Y is equal to 100, we have to find out the value of X. That means for 1 quintal, how much will be the price? That means for 100 kgs, what will be the price? So in place of Y, we'll substitute 100. So X is equal to 90 into 100, which is 9,000. Therefore, the cost of 1 quintal groundnut is 9,000 rupees.